this example, we're again given an equation of an ellipse. This time, however, it is not clear what the major or minor axis distances are or where the center of the ellipse is. The h and k values, the a and b values, those are all kind of in disguise here. Our polynomial is completely expanded. And so what we need to do first is complete the square in order to, both for the x and for the y, in order to get our equation into the standard form with the x minus h squared and the y minus k squared terms. And then of course we're going to have to divide out whatever constant is on the other side in order to create either our a squared, b squared combination, or vice versa, maybe the b squared and a squared, however that's going to play out. Okay, so the first thing I want to do is group together all my x terms and all my y terms, and then move the constant to the other side, and then we'll work on completing the square. So first thing I notice, I've got an x squared and an x. I'll get those together, 2x squared minus 12x. I'm going to leave a little, well, no I'm not. I'm going to go ahead and fill this in. I'm going to have my y squared and my minus 2y. I'm going to move the 11 to the other side by subtracting it from both sides. Okay. Now, I should go ahead and maybe I'll do this as a 2-column problem so you can see how this might work out if I was using my property index to give some reasoning here. So the first thing I did is I subtracted the 11 from both sides. That is property EQ1. That's the code from the property index for adding or subtracting the same amount to both sides of an equation. The next thing I would do, to complete the square, you always want to have a leading coefficient of 1 on your x squared. Okay, so here on the, on the y squared or the x squared, here on the x squared I have a leading coefficient of 2. I'd like to remove that coefficient or factor it out. And so from these two terms I'm going to pull out a 2. That would leave an x squared minus 6x. And from the y's there's really nothing there. I'm not going to worry about pulling anything else out because the leading coefficient is already 1. The step that I just took was to factor out a greatest common factor. It's actually the reverse of the distributive property. If you think about it that way, you know, you could distribute the 2 in or you could pull the 2 out. It's really the same property. On your property index, that is called poly 2 for the distributive property. It's just doing that in reverse, switching the equation around. Okay, so the next thing I would do here is try to figure out what constant is needed on each of these groupings in order to create a perfect square trinomial. Remember, when you're completing the square, you're looking to create something of the form a squared plus 2ab plus b squared so that it can be factored into a plus b quantity squared, or it could be a minus there. If this first term, middle term is a minus, then that middle sign will be a minus as well. Okay, so we want something in the form of this top structure to get the factoring into a square. So here, what I notice is that if my x and my a correspond, then the a is taken up by the x, so the 2b must equal to 6, which means to find the b value, I just cut that 6 in half. That gives me a 3. So that gives me a 3, and then I need to square that 3 to put it back in, so that would be a 9. I'd have to add 9 here. So x squared minus 6x plus 9, that completes the square. However, I didn't really just add a 9, I added an 18 because it's really 2 times 9 that I just added to the left side. So to balance the equation out, I should add an 18 to the other side as well. Alright, so let me get rid of this, make some space. Over here on the right, I'm going to have this minus 11, I'm going to have a plus 18. that balances out this 18 that I just added in. Now let's look at the y's for a moment. Again, if I cut this in half, I get a -1. If I square that -1, I would get a +1. So my quantity here is going to be y squared minus 2y plus 1. Now, I'm adding a 1 on the left side that wasn't already there, which means I also have to add that to the right side. Right? So I added an 18 and a 1. On the left, I have to add an 18 and a 1 also on the right. Right? Now, the step that I just completed, was another EQ1. That's the addition principle of equality. I'm just adding the same amount to both sides of the equation. Okay? It looks a little bit complicated on the left, but that's really all I'm doing, is I'm adding a total of 19 to each side. Now I'm going to go through and do the factoring and combine like terms. So here, this perfect square trinomial factors into x minus 3 squared. And on the right side, this perfect square trinomial factors into y minus 1 squared. And on the right side of the equation, -11 plus 18 plus 1, if I add all those up, well, -11 and 1 is -10, and 18 is 8. So I just get an 8 there, right? The property that I used on that step was the factoring property for the perfect square trinomial. You'll find that under the polynomials on your property index. That is poly 4, if I'm not mistaken. All right, so from there, I do need to divide out the 8. Remember, my standard form needs to have a 1 on the other side, so I'm going to go ahead and divide out this 8 on both sides of the equation. So divide it on the left, or on the right, and divide it on the left here, distributing it to both of the main terms. Now, here 2 over 8 reduces down to a 4, and over here the 8's reduced down to a 1. And so my final form is going to be x minus 3 squared all over 4 plus y minus 1 squared, square doesn't look good, squared, all over 8 is equal to 1. Now, the step that I just did there, I divided both sides by the same amount, so that would be your property EQ2. That's the multiplication or division principle of equality, dividing both sides by the same amount. Now that I have it in the structure, I can go ahead and identify the 7 key points. In fact, to do that, I'm going to erase all the work here, except maybe I'll keep the original equation intact. Okay, and I'll rewrite this. So it's x minus 3 quantity squared over 4 plus y minus 1 quantity squared over 8 equals 1. Perfect. Now I have some space to work. So now I need to get my 7 key points. Well, the center is the obvious one, right? It's 3, 1 using the opposite signs. And the orientation of this ellipse is going to be vertical. The major axis is going to be in the y direction, the vertical direction, because the larger denominator is on the y. All right, so major axis, minor axis. So on my equation here, I'm going to swap the a and the b, because I want the bigger one, a, to be underneath the y, and the smaller one, the b, to be underneath the x. Okay, now I need to figure out what the a and the b are going to be. Well, the b value is the square root of the 4, so that'd be 2. The a value is the square root of the 8. The square root of 8 is 2 root 2. And of course, I need a decimal for that, otherwise I really can't plot the graph. 2 root 2 is about 2.8 roughly. So approximately 2.8. Okay? Okay. Now I can also find the c value based upon that information. I know that b squared is going to be 4, so I have 4 equals a squared is 8 minus c squared. If I subtract the 8 off, I get negative 4 equals negative c squared. I can divide out the negative and take the square root, so c is going to actually be equal to 2 as well. All right, that's nice. That works out well. Okay, so now I can figure out all of my points. So let's go with the vertices first. Okay, so vertex 1. Let's go with a major axis. Along the major axis, we have vertex 1. Now remember, what we do is we look at the a value. The a value for the vertex is 2.8, right, square root of 8, and that's going to be in the y direction, so vertical. So that's in the y direction. So I want that 2.8 to be the y, in the y component. However, I still have to adjust for the center, for the horizontal shift of 3 and the vertical shift of 1. So I combine the 1 with the 2.8, that gives me 3.8 for the y value. Okay, so that's my 2.8, but then also shifted up 1. And then the shift 3 gives me a 3 in the x coordinate. For the second vertex, you know what I just did? I just did vertex 2. I guess it doesn't matter which one's which. I tend to use vertex 1 for the negative, or the lower one. It doesn't matter. I got it in the higher one. That's fine. The second one, let's do the negative now. Let's do the negative of the 2.8, and let's add the 1 to that. Well, that will give me a negative 1.8. And that again is in the y component, or coordinate, and then the 3 will be in the x again. Okay. So that's our major axis. So the whole major axis, you imagine, instead of being on the y-axis, is shifted over 3. So both those points will be lined up with an x value of 3, but then it shifts up 1. So that's where you get the 3.8 and the negative 1.8. Okay, so it's this value plus and minus shifting up 1. Then we do the foci. The foci come from the c value, which is 2. So again, I take the 2, I add the 1. That gives me a 3 in the y coordinate. But this is all in the major axis, so the x coordinate is already this 3 here. Okay. For the other focus, again, I keep the 3. 3 on the x, and then the y is the negative of this value, the negative 2 added to the 1, that'd be a negative 1. Okay. And then finally, for the minor axis, and if you're not comfortable just kind of adding the right coordinates together to get things in line, I would recommend just using the table in your textbook, which has the actual, for the foci, for the focus, you might have, it'll say h comma, k plus c or k minus c or whatever, and then you just plug in the values as needed and calculate it. I think of this more visually. I don't like the formulas because I don't like to try to keep track of what's what. I just try to imagine everything on that line and just fix the x value and then just shift all the y values. And then for the minor axis, it's a little bit different. You fix the y value, everything is horizontal, and you just shift the x's back and forth. So for the minor axis, we're looking at the b, and that's going to be in the horizontal, or the x component. So you take the b, put it in for the x, but then you've got to add the 3 in, so that's going to give you 5 comma 1. Now it's fixed at 1 unit high. And then you also want the negative 2 with the 3, that gives you a 1. comma 1. Alright, so you start with you have the 3, you either add or subtract the 2. That gives you the 5 and the 1, and then you fix this 1, that's your vertical shift. Okay? From that, I have all 7 of my points that I can now plot. I'm looking at those, they're mostly all positive with the exception of these 2. So I want first quadrant values primarily, mostly less than 6. And with just a couple negatives there. So, and those are negative y values. So, let's try to sketch my axes, try to get a decent graph here. Alright, let's go 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. That should be plenty of space, maybe too much again, we'll see. So now I plot these points. 3 comma 1 is my center, so over 3 up 1. Then I have the major axis points. Again, that's going to be my vertical axis. In fact, I could even draw it in just so I know everything's going to be on that line. 3 comma 3.8, so over 3 up 1, 2, 3.8, right about there. And then 3 comma negative 1.8, so down 1.8, right about there. Then I have then I have 3 comma 3, just double checking my arithmetic, and 3 negative 1. Yeah, something's not adding up right. Something's a little fishy. This gap is bigger than this gap, and I don't like it. No, it isn't. No, that's a 0.8 gap. Negative 1, oh, that's a 0.8. Never mind, we're good. I don't know what I'm thinking. It works out. Then, let's see, I got my minor axis. That'd be 5 comma 1. 1, 2, 3, 4, 5, comma 1. My minor axis runs this direction. And 1 comma 1. That'd be right here. Alright? And so my ellipse just connects all the outer points. Almost went to the focus there. This is definitely the tricky part, is trying to draw these in a way that actually looks decent. Oh, good grief. It's just not close enough. There we go. Okay, that's not too bad. Takes a little bit of erasing and fixing, but it doesn't look too bad. So again, this one is oriented vertically with that major axis going parallel to the y-axis, and then your vertices are on the outside, your foci are on the inside, your center is on the inside there, and then the minor axis points are across the ellipse. So hopefully that makes sense. There's quite a bit of work involved in this one. First in completing the square and getting the equation in the right format, then picking out all our points, shifting them around, and then finally sketching the graph. So again, not a simple problem, definitely takes a little bit of time.